everyone. In today's video, I'm going to show you how we can download rainfall data, grid rainfall data, of course, automatically, and how we can export this data into Excel format, which is easy for us to read and write into different formats. So the first of these, we have to call these libraries for further operation and to read our shape file, and we're going to give the address of this data. This data is a well-known gridded data set, rainfall and a data set particularly because it includes like developing countries, and its focus is to monitor drought and other actually rainfall variability and soil falls over Africa particularly. So it is net, and this data is freely available online. Everyone can download and use this data for the study, any study. So the data is gridded, and it can be either in TIFF formats. TIFF is the pictures and plots, but other one is netcdf file format. I'm downloading here netcdf file format because the good thing about netcdf file format, we can download as a single file all data, because it enables us to write 3D variables, for example rainfall in different time period on every latitude and longitude values in every boxes in that case. So we download this data from this link. This link is easily is the link for this data set. We can go into this CHC usb.e2, or we can search on the Google CHIRPS dataset, and we go here. That is Climate Hazard Center at the University of Santa Barbara, which is in US California. So we can go here, and then this is the link. This is how the data looks like. This is their example, and we go either of these links, and we say daily data set. Daily data is in TIFF format, and monthly, the other product is, of course, this product is if we go here, CHIRPS products 2, version 2. So we can go here and see the availability, for example, the global daily, global annually, global 3 monthly, and so on and so forth. And we are here interested by the global monthly data set. So here we go not actually 3 monthly and 2 monthly, every 2 months. That means we go maybe here annual data set. We go here netcdf file, and we can download this, or we can copy including the name of this. Normally, if I click here, it's going to automatically download about this megabyte data into my local machine. But here, if I copy this and I give the name of this normally there as a link, it's going to download all this data. And the other one is, if we are interested, for example, global monthly data is here also. I downloaded this one. Fortunately, that is 7.1 GB data globally available, and I downloaded this one at a time. So we can copy the link, this link, and we add the name at the end of the link, and then we give this URL address to the downloading actually part. And as I've shown you, this is we give like as assignment variable URL. This is the address. Address must include like at the end of the net CDF file. We have to include the whole, the available file name there in the link. Then after bringing that, we use like from curly package here. We're going to use like curly download function. You are like curl download function here. So this is URL. We're going to give that URL here, and we give how it's going to write this particular file as when we save into the system. So I download and save this already into my machine right now. So then after downloading, and we know the name of our file, including, of course, it takes some time depending on your internet connectivity and depending on the speed of your machine, and so on and so forth. So then after waiting some time, uh, after completing actually download, we're going to proceed like reading that file back to our system normally. So to do this, we're going to read that particular file into our system right now. I read this particular file to my system, but like here you can see the file does not exist. That is because I changed the directory from somewhere to somewhere. I should adjust that one to the file where the file is located. So I go here like session, and I have to change the directory. Choose directory, and it's under the document, I think. So I will give it a try again here. That is, I have already changed the place. That's why normally now I able to read this file because it's there in the place. So that could happen in R normally. So when that happen, like when you could not find your location of your file, you change easily. You look where is your file is located, then you simply change the place to the exact place where your file is located. Then you can read your file directly to the R. Then right now, what I should do is simply I change again the directory where my shapefile is located. Now I'm interested to generate this data, not really globally. That is like too much for my machine to write, but I have to clip this particular data to Amara region, and then I have to generate from there a export as a Excel file. So to do this, I have to change directory where my the shapefile is located. I read Ethiopia shapefile. In Ethiopia shapefile, I have also like I have to set out only the region of my interest. That is for now. I'm working this example for Amara region. So I subset Amara region out of Ethiopia, normally giving like my shapefile as which is Ethiopia here. I take out only Amara region. Then I make this region into vector, which is like more of the same format a the file I going to crop. So I my file name here is read as trip, so I give trips, and then I crop trips for exactly for Amar region only. So I've got error here. I don't know why that happened again. Okay, then I have to go back. Empty vector is created somewhere. Amhara. So I have to look again here. Maybe here I have to like Amhara is as admin one here. So that was the issue. Then I clip for Amara region. I crop my whole global data only for Amara region. Then I mask others out again. It takes some time, of course. I have to wait a little bit. That basically not depend on the internet, but it depends on our speed of our machine, normally our computer. So we should wait like it's working here, and we can see that my machine is busy of like cropping this only for the region. So then after this complete, we proceed with masking that. That doesn't take that much area, that much time, because it's already cropped for that particular region once. So we will do this after completing this particular action. This particular task is, I mean, it's taking too long. I don't know. So, but there's nothing wrong normally. So that takes some time, and we should wait for some time. Then we proceed with cropping. I'm overwriting here, like I'm using the same name here and here and here, because I don't want to like overload my PC. I want to overwrite one on the top of other. When R writes this one, it's going to delete the previous file with the same name normally. When I give like I read like trips here, when I write again trips, so it's going to replace the first one, and when I write again on the top of that one, and it's going to replace the previous one in any time I'm having the same name normally. So that's why we have to be careful when we are doing in R. We have to make sure our names, like the name that we assign our data, is if we want to keep normally that particular file for the further process, we should not write the same name. We should assign different names if we want to remove the previous file. If the previous file is not necessary to reproduce or to, I mean, to use in further activity, we should remove the previous one, and we overwrite on the top of the previous file name. So that is how it's going to, I mean, going to work. And still is not completed. I don't want to interrupt, but I could maybe continue with next activity. But next activity always wait for the previous activity. If the previous activity is something, I mean, wrong, the second activity cannot be, I mean, run, because of the it depends on the previous activity. That is, I mean, in every maybe data analysis software that works, that holds true. Fortunately, both of these activities are successful. Then my data is like a monthly data, as I have shown you previously. It is from 1981 January to 2025 December. So this is monthly. I have to assign this to my data, and I have to see like the time of trips. So when I see like the time of trips, this is like from here to, as I shown you, like it's for this much months. Like you can easily see there. is like 540 months from this to this. So if we want only like average for the region, I mean average for the Amara region for each month, we need to calculate like a global average for the each time. I mean each time, like for the 1981 January, the regional average, for example, the global average means here is not really, it does not mean really global, but for that particular region, but over the time, over each time. So in that case, it calculates only mean for like, I mean, there are different grids. So, like if there is 30 grids in Amara region, so it brings 30 grid together for the one time. I mean, time average of the time. So that is how we're going to calculate the time average. Then after calculating that, we're going to assign a time that we as a date, and then we extract only a rainfall like data frame, and this is now rainfall. We can see only maybe head of this, sorry, head of that, I mean like df, that is our variable. We can see only like top of this uh, data, like here is rainfall. So after seeing like the head of this data, we can see it looks like this. This is the average of the every grid together for a time. Then we're going to write using write Excel or write uh, as write CSV function write dot CSV function. Then we write like as a comma separated file. So we're going to have this file now in the same folder normally. So we can read this file back in our folder normally in this case. So the other case is if we are interested for data over the time over every grade, for example. So that can also be done easily. For example, if we need to produce a map, this produces only like a time series that can be plotted as a line, or that can be maybe analyzed as like we're going to calculate variability and it is. But if we would like to produce normally what's so called the maps, and if we want really like spatial analysis for the region, we need to see like the number of layers is like, I mean, how many layers are there for that one, or we're going to see only like time. And then after we're going to read, of course we can ignore this one, it's not that important, I can comment it out. And then I read like these trips as xy true normally as it is into the data frame, that is xy is latitude longitude is included. If latitude and longitude is included, that means our data is gridded, but it is in the form of Excel, not in the form of a netcdf file, which is actually hard to understand for many of us. So now I read this as a data frame, but this data frame is actually turning into data frame. It takes a little bit time because my area is a little bit large area, and then I'm going to get like a data frame for all time and for all grid cells. Then to modify my data, I need a tidier and declare a package. So after that, I give the name for my my data, as the data frame that I've produced as a point, like the first three column must be like I mean the first two column are latitude and longitude, so that should not be changed. That should keep as it is. But I changed the other column like the name and name of the month, and on the name of month I'm going to add I mean the time of the year. So to do that, I'm going to change like the name. And of course, I can see like the first few points at as here. Then in the head, I'm going to put PTS so that we can see the first few lines. Uh, of course, the lines are too many because there is too many rows and too many actually. Oh, that is sorry, it's too big. So like too many rows and months is actually like months number of the months is from as I told you from the first month to five I mean 540. That is the months normally like month one, month two is here, xy is like longitude and latitude is here, and the number of series of months is then after having that I have to change like a long format that was like in every month is like listed like I mean what's so called in a horizontal way. I have to change this into the vertical like the first row longitude, latitude, and the third must be normally only rainfall in different months. So to do that, I have to put points and I have to change into the long format, and I have to give like the starting with months number one in this case, month number every I mean from the start to the end, and names to actually like from layer to rainfall. I have to change like rainfall in millimeter. So now I get x, y, and rainfall on the third column. So I have to change this. I have to run this. That might take a little bit time. No, in this case, not at all. Then I see like the head of this df. I mean df long. So this df long looks like this normally. Yes, it's here like x, y, layer is like the months from 1 to I mean x 1 to in my case I know the last one is 540 and the rainfall values and the second. Then I have to change like maybe from this format like date from the months 1 2 months x to the dates actually these two dates. Normally to change that I have to put only this one, and then dates must go there. Now like I have made a sort of modification on my data. Then if I see the head of this the same data set long normally, so this is how it's going to look like. So here is it. Like date is here from 1981 first month. Of course, we're going to have first month for I mean for every grid. So that is important for mapping. For every grid, there must be like the first month for every grid, first month for second month for every grid. For example, grid X should have first month, second month, grid Y also should have that, grid Z should have that, and blah blah and extra. So then I have to write out this one into Excel as I've shown you earlier, like you're going to write X, I mean XLS that could also write like with CSV, or we can going to use like only automatically CSV. Then CSV is like only comma separated Excel file. So it's totally fine and it looks like Excel. So this is how actually we're going to generate or export our netcdf data, either it is in temperature data set or rainfall data set. This is how we're going to convert from a netcdf file or TIFF file. That is also fine. It works like in the same way. So into the Excel format file, and I really kindly ask you actually to subscribe my channel. And if you have a question and comment, you can drop here below. I know I have answered and I have extracted for many students actually from netcdf file to Excel file, rainfall data and temperature data. So this is actually the intention. My intention here in this video is to enable you actually you can yourself extract your netcdf data. You can download by yourself and you can extract or export from netcdf to Excel, which is easy and easy to handle format. So thank you for watching my video and please subscribe my channel. Thank you once again. So that is it.